Hey guys, Dr. Brown here, and we're still on the series of where did they get that formula. So tonight we're looking at the integral of secant squared x. Now we know it equals tangent x. And in the Calculus 1 videos, we've actually used the limit formula and calculated that tangent x does in fact equal secant squared x. But what if we went the other way? Took the integral of secant squared. This has a few unique turns in it, I think. It's an interesting problem. Okay, so let's get rid of the secant. Well, let me scoot my computer over to get more cord here. All right, let's get rid of secant and put this as 1 over cosine squared x dx. Now, it was at this point that I'm looking at, well, you know, I really need a sine x in here. I need that. And so I thought, well, okay, 1, we know from a trig identity perspective, that's sine squared x plus cosine squared x. So let me put that as sine squared x. I'm just going to put the cosine squared x under that plus cosine squared x over this cosine squared x. That's a bad looking C. Okay, all of that dx. Well, cosine squared x over cosine squared x, that becomes 1. So now I have sine squared x cosine squared x plus 1 dx. That integral. And now, this is where I got stuck for a while. What are the tools that are available to us? I mean, we have U-sub, trig sub, integration by parts, power reduction. Actually, power reduction is something I started with up here. What if cosine squared x, I change that to 1/2 1 plus cosine 2x. You know, that's a formula that's out there. So I went down that path. Well, I didn't get where I needed to be. So I had to come back. You know, we have, with the power reduction, there's always long division, which doesn't fit here. There's partial fractions, which doesn't fit here. Complete to square doesn't fit here. So now you're down to, if I had sine over cosine squared x, I know in previous problems we've worked, I could do a U sub with that. So if I had sine x over cosine squared x, and I'm taking that integral, well, I would say, and that's with respect to x, so I would say let u equal cosine x. Du then equals minus sine x dx. So if I isolate the dx, divide both sides by negative sine x, that equals dx. So what would that give me? It'd give me the integral of sine x over u squared. U is cosine x, so it's u squared. Replace dx with du over, and I'll put that negative outside, negative sine x. So the sine x's cancel. So I have negative the integral of u to the minus 2, to the negative 2 du. Well, if I increase that by 1, that's negative 1. Divide by negative 1, the negatives cancel. And I end up with u to the negative 1. Well, u was cosine x, so that would equal 1 over cosine x. And you're thinking, well, big wooey, you don't have just sine x over cosine x, you have sine squared. Okay, so let's just separate the two, because if you think about the tools, U sub, trig sub, and integration by parts were really the only 3 tools that I had. Okay, so let's move up here. We had the integral then of sine x over cosine squared x times sine x plus 1, I'm going to separate these two integrals out, plus the integral of 1 dx, or just dx. Hey, okay, now then, what about integration by parts? Because we know we can integrate this, and I know I can differentiate that. So let's try that. We'll put it here. So we've got a di, and we're going to integrate sine x over cosine squared x, and we're going to differentiate sine x. Well, we just integrated sine x over cosine squared x, and that was 1 over cosine x. The derivative of sine x is cosine x. Okay, so now what do we have? We have sine x over cosine x. So this integral here would be sine x over cosine x. Now we have to integrate this piece. Well, I have negative cosine x over cosine x. So I have negative the integral of cosine x over cosine x dx plus this integral here plus the integral of 1 dx, or just dx. So what do we have here? Sine x over cosine x minus cosine x over cosine x is 1. So minus the integral of 1 dx plus the integral of 1 dx. So these two cancel each other. And I'm left with just sine x over cosine x, which is what? Hey, tangent x. And that, my friend, would be how you would integrate secant squared x. Why are we doing this? Hey, together we're trying to build a better tomorrow and do that through math. Get linked up, and I say this every week, get linked up with a local school, help out some kids, buy some books or whatever supplies that school or teachers need, and let's help these kids build a better tomorrow. That's all for now, and we'll talk to you next time. Thanks.